Hey Metzger, welcome to Chem Exam Prep. We are in Module 3 and now we're going to dive into the training. We saw in the first video when we reviewed it, it was related to the empirical formula and we got a lot to cover here, so let's get going. So let's go into the definition of empirical formula. Empirical means it's from data, right? It's empirically driven. It's not from a calculation. But I think the key thing as you understand the empirical formula, it is the lowest possible ratio of atoms. So here's an example. CH2 is the lowest ratio in empirical formula of the molecule C3H6. So take a look at the ratio. You know, it's basically 2 to 1. In this case, you have 3, you double it, you get 6. So here's empirical, and there's the molecular. Now, if you take a look at the ratios of atoms in a molecule, you can see that the subscripts tell you the ratio of atoms in a molecule, and then we use moles to count things, right? The definition of mole, it's just like you can count cases of pop or you can count moles of pop. So mole is just a counting definition. But if the subscripts give us the ratio of atoms, then technically they also give us the ratio of moles of atoms. So here's an example. Calcium chloride has 1 mole of calcium atoms, it has 2 moles of chlorine atoms. Because again, it's just a counting. So number of atoms and numbers of the ratio of atoms of A and B is going to be similar to the ratio of moles of A to B. That's key. So if we know the ratio of moles of each atom is found, then we can then go back calculate the subscripts of the chemical formula. So we use the mole ratio of atoms in a molecule to figure out the empirical formula. So here we go. Here's the 4 steps. If you're given percents in these questions, you use the percents as grams, okay? So you just say you just assume 100 gram sample, and then the percents of course have to add up to 100. Then you do gram to mole conversion for each atom. Then in step 3 you find the lowest whole number ratio of the atoms. So in this case you just divide everything by the smallest number of moles, and then you use a ratio of the subscripts for writing the chemical formula. So let's do an example. Find the empirical formula if a sample contains calcium and chloride and it's 36.1% calcium. So here's your setup. It's basically it's calcium and chloride, that's it, and this has to equal 100 grams. Convert these to moles, so you have to use the molecular formula to go from grams to moles. This is just a dimensional analysis that has been covered in your class, so now we can convert these to moles. So 36.1 grams of calcium is 0.901 moles of calcium, and then you have 1.80 moles of chloride doing the same exercise. You divide by, let's move this out of the way here so you can see. You divide by the lowest number, right? That's step 3. So you get 1 mole of calcium. You need that whole number. And then you do the same thing. You divide by that the small number and you get 2. So now we got our ratio 1 to 2. So that gives us the empirical formula. All right? Let's do one more example. Find the empirical formula if the sample contains 40.92 grams of carbon, 4.58 grams of hydrogen, and 54.5 grams of oxygen. So in this case, if you add this up, it's probably 100 grams total. And then here's our molecular weights. So we do the quick math to convert to moles. And then we have to divide by the smallest number, in this case 3.41. And then we can determine our ratio. And so we get 1 to 1.33 to 1. And obviously we can't have this fraction, so we just divide everything or multiply everything by 3 to get rid of that, and so we get a 3 to 4 to 3 ratio. So there you go. The definition of molecular formula now is just the actual ratio of atoms in a molecule. So the difference is the empirical formula is the lowest possible ratio, and the molecular formula is the actual ratio. So in this case, a molecule with the empirical formula NO2 can also be NO2, N2O4, and 408. It keeps the same ratio, okay, in the molecular formula, and so you can see the connection there. Here's CH2, and you can figure out with the molecular formula you can you just have to, if you know the molar mass of the molecular formula, you can determine from the empirical formula how to get molecular formula. You can pause the video and you can take a look at how we did that here. Alright, so in this case you took the empirical formula ratio, you converted it to moles, and then you just divided that into your molecular thing to find that you just take the empirical formula times 2 and you got the molecular formula. That's how you do it. Thanks. Bye.